In the video from ETHS PhysVid, he took you through the steps that you take in order to take a quadratic graph, which is curved, and turn it into a linear graph, which you could then use to figure out the equation of a graph in the form y equals mx plus b. The problem is that sometimes it's not quite so easy to figure out whether something is quadratic, whether something is cubic. And in this lesson, I'm going to take you through the steps that you can take in order to determine the type of relationship. Most relationships that we deal with in physics involve one independent variable, and it's somehow proportional to some exponent of the dependent variable. So y is proportional to x to the power of b. And when we want to create this linear graph, we need to figure out what the b value is. When you have a graph that asymptotes both the x and the y-axis, then you know that there's going to be a negative value for b. Whereas if you have a graph that curves downward like that, that doesn't necessarily mean it's going to be a square root function, but it does mean that the value of b is going to be somewhere between 0 and 1, so some kind of a decimal or a fraction. When the graph curves upwards, you might think it's quadratic. Well, maybe not. Maybe it could be cubic, it could be quartic. It just means that the value of b is going to be bigger than 1. So if you look at these three different examples of y equals x squared, y equals x to the x cubed, and x to the fourth, you see that they sort of have a very similar shape, except for that the x to the fourth graph is much steeper, whereas the x squared graph is much shallower. And so when you're just looking at a section of one of these graphs, you can tell maybe that it's curving upward, but you won't necessarily be able to tell which one of these you're looking at. And so that's the motivation behind this. There's two different ways that I know of to do this. One way is using a power regression method, and the other method is using a log-log method. I think the log-log method is probably more common, but I'm going to show you how to use a power regression. Okay, first thing you got to do when you're setting up your file and input the data. First thing though, we should set up the headings. One thing that's nice about this program is that when we set up the headings over here, they automatically correspond to the axis labels. Here we go, we double click over here. Then we type in the name of the x variable, and the data that we're going to use is the data from your note. So basically what we're looking at is we're looking at the price of an item, and we're going to use P, and that's in dollars. And we're going to compare that with the number of items that end up getting sold. Number sold, and the short name is N, and there's no units for that one. So the data in your notes is basically that we have 5, 6, 7, just type it in. Okay, so the data's in right now. Some of the defaults of Logger Pro are a little bit annoying, so we're just going to change this up to make it look a little bit nicer. First thing you always want to do is you want to adjust your axes so that it fits the data. Nice and easy way to do that is to just click the A button up here, which is the auto scale button, and it automatically fits the screen to the data that you have. Unfortunately, we don't really see the data here. So what we have to do is we have to double click on the line of best fit. We want to add some point protectors, which are little circles that go around the points. We do not want to connect the points. And I think that's it. So this looks a lot nicer because we see our data points. We see that they have some kind of a nice curve, and we know that it has to be some kind of an inverse relationship. So our b value has to be negative some number. So in order to figure out what that negative number is, what we do is we go analyze, and we want to do a curve fit. And the curve fit you use for this would be a power regression. So we go down to the power regression formula. We click on the power regression. We try a fit. Okay, and it automatically shows us what the relationship is. This relationship has a bit of extra information. We don't really want to see the uncertainties. And we probably don't want this many significant figures. That's probably good. Maybe even less than that. Okay. So what we have here is we see that the b value that ends up being produced is basically negative 0.98. What that tells me is that this relationship is likely to be an inverse relationship, a straightforward inverse relationship where the b value is negative 1. Now that we've shown that the relationship is an inverse relationship where n is proportional to p to the negative 1, we can follow the steps that were discussed in the video, in the previous video, that produce a linear graph from this. So the first step that we need to do is we need to come up with another column showing the new values of when you raise price, when you raise each of these price values to the power of negative 1. Now this is much easier to do in Logger Pro than it is to do by hand. What you do is you go analyze, you go data, new calculated column. And this calculated column is going to be price to the power of negative 1. It's going to take me a couple seconds here. The short name is p to the exponent of negative 1. And the units are going to be $sign to the power of negative 1. And then the equation of this, we have to refer to one of the other columns, and we're going to raise it to the power of negative 1. So the symbol that we use here is the little upside down V on top of the 6 on your keyboard. You go none. And what it does is automatically takes every single price value you have in there and raises it to the power of negative 1. So you don't have to do each calculation. Now our graph still shows price versus number sold, but we want to see price to the negative 1. So what we do is we just click on the label down here and we select price to the negative 1. And this it shows our data now where the horizontal axis is representing price to the negative 1. So what we're going to have to do in order to show this data better is we need to readjust our axes. Looks pretty linear to me. So we're going to insert a linear fit, analyze, linear fit, and it produces a straight line. The line doesn't entirely fit the data, but it's close enough.